By the early 20th century, scientists had already established the first, second, and third law of thermodynamics. This law covered the conservation of energy, the flow of entropy, and the behavior of matter at absolute zero. However, in the 1930s, British physicist Ralph H. Fowler realized this principle was so fundamental that it belonged before the other law, even though it was formulated later. The existing law assumed you could measure temperature, but they didn't provide the logical basis for how a thermometer actually works, because the first three laws were already widely accepted and numbered. Foley suggested naming this foundation principle the zeroth law so it could precede the first law. So, what does the zeroth law actually say? The law states that if two systems are each in thermal equilibrium with a third system, then they are in thermal equilibrium with each other. In simpler terms, if object A is the same temperature as object C and object B is the same temperature as object C, then object A and object B must be the same temperature as each other. A simple example of thermal equilibrium in daily life is placing a cool spoon into a hot cup of coffee. When the two objects come into contact, heat flows from the hot coffee to the cool spoon. As a result, the temperature of the coffee decreases while the temperature of the spoon increases. This heat transfer continues until both the coffee and the spoon reach the same temperature. At this point, thermal equilibrium is achieved and no more heat flow between them. To determine whether two systems are in thermal equilibrium, three key conditions must be met. First, equal temperature, which is both systems must have the same temperature. Second, no need heat flow. Although particles in both systems continue to move and collide at the microscopic level, there is no overall transfer of heat from one system to other. Lastly, time stability. The temperature of both systems remain constant over time provided they are isolated from any external influences.
Next, we want to understand how temperature is measured in a scientific and consistent way. This brings us to the zeroth law of thermodynamics. The zeroth law states that if two objects are each in equilibrium with the third system, then they have the same temperature. In practice, the thermometer acts as this third system as shown in the diagram. It serves as a reference point between two objects, allowing us to determine whether they have the same temperature without comparing them directly. This is why thermometers are essential tools providing consistent, accurate, and meaningful temperature measurement in both scientific and everyday situations. Thermometer work because certain physical properties change when temperature change. For example, liquids in thermometer expand or contract depending on temperature. Digital thermometer detect changes in electrical resistance, while infrared thermometer measure radiation emitted by the object. These property change are carefully calibrated so that the thermometer provides stable and accurate readings. This allows temperature to be measured reliably and consistently, making thermometer useful in both scientific experiments and everyday life.
This slide presents the main temperature scales that are commonly used. Temperature refers to the degree of hotness or coldness of an object. The first scale is Celsius, which is widely used in everyday application and in scientific work. In this scale, water freezes at 0 degrees and boils at 100 degrees. The Fahrenheit scale is mainly used in the United States, where water freezes at 32 degrees and boils at 212 degrees. And lastly, Kelvin is the SI unit of the temperature and is primarily used in physics and thermodynamics. It begins at absolute zero and does not use a degree symbol. Overall, each temperature scale serves a specific purpose depending on its application.
So now we will show how science is applied in real life, specifically in food safety, industry application to ensure safety, quality, and efficiency. In food safety, a temperature probe is used to check the internal temperature of meat such as chicken and beef. This is important because harmful bacteria cannot be seen with our eyes. By using the probe, we can make sure the meat is cooked at a safe temperature and is safe to eat. This helps prevent food poisoning and protect our health for industry. In industry, especially in chemical factories, sensors are used to monitor temperature and pressure during chemical reaction. This sensor helps ensure the reaction occurs at the correct equilibrium point. Maintaining equilibrium is important because it improves product quality, reduces waste, and helps prevent accident in the factory. This slide shows why the zero law of the thermodynamic is very important. The zero law gives the physical meaning of temperature. It allows us to use a thermometer as a middle reference to compare different objects. It also explains thermal equilibrium. When two systems reach the same temperature, heat flow stops, so Q equals zero. Lastly, this law made our measurement consistent worldwide. Whether we use Celsius, Fahrenheit, or Kelvin, the zero law ensures the temperature readings are reliable and repeatable everywhere.